Hey there, I'm Joe Carter. If you've ever popped the hood and thought, where do I even start? You're in good company. Around here, we take the mystery out of car repair, one fix at a time. Whether you're a beginner or just looking to sharpen your skills, there's something here for you. Don't forget to like the video and subscribe if you're into learning without the headaches. All right, that's enough from me. Let's get into it.
The principle of operation of the generator is the conversion of mechanical energy into electrical energy. This happens due to the phenomenon of electromagnetic induction. The essence of it is that when an electric conductor crosses the force lines of the magnetic field, potential difference arises at the ends of the first. That is, electric voltage. The principle of operation of the automobile generator is the same. The car alternator is an alternator with a rectifier built into it. Why a car needs an alternator? Every automobile needs electrical energy to operate. It is used to start and run the engine and to light the road. Control devices and light indication also use it for normal functioning. Therefore, the electric battery is quickly discharged while the car is running. A generator is installed on every vehicle equipped with an internal combustion engine so that it can be recharged while the engine is running. Rotor, consisting of a core with 6 poles and a coil of insulated copper wire wound inside this structure, the leads of which are connected to 2 copper contact rings. This coil is the excitation winding of the autogenerator. Rectifier diode block. Its circuit consists of 6 powerful diodes located on 2 aluminum horseshoes and connected in pairs. The method of their switching here, as a rule, is the Larionov scheme. This circuit converts a 3-phase AC voltage into a DC voltage. The duralumin case of the autogenerator with the output terminal isolated from it, and with the elements of attachment to the motor. It is made of 2 halves, front and rear, fastened together by long bolts with nuts. Voltage regulator with brushes. In earlier autogenerator designs, the voltage regulator was not combined with the brush unit, but was installed separately in the engine compartment. The wiring diagram of an autogenerator with built-in and remote voltage regulator is somewhat different. Interference suppression capacitor. Serves to reduce interference with radio equipment in the onboard network of the car. It is connected in parallel with the generator output, that is, one of its leads is connected to the plus terminal of the device, and the other to the mass of the car. Drive pulley, often connected to the cooling impeller. Alternator diagram. The voltage regulator circuit is, in fact, a current amplifier with negative voltage feedback. That is, increasing the voltage at the output of the autogenerator leads to a decrease in the current flowing through the rotor field winding, which weakens its magnetic field, and because of this, the voltage at the output of the device decreases. In modern generators, an additional rectifier of 3 low-power diodes is used to supply the field winding. This eliminates current flow through the field winding when the ignition is off and simplifies the scheme of indication of the presence or absence of charging. When the ignition is turned on, the voltage regulator is energized through the indicator lamp. While there is no charge, the alternator excitation current goes through the bulb and it glows. And as soon as the alternator starts producing power, power is supplied to the regulator from additional diodes, the current through the indicator light stops and it goes out. The rotation of the rotor by the motor through the drive belt causes the magnetic field force lines to cross the turns of the stator windings. This generates EMF in the windings, and alternating electric voltage appears at the winding terminals. A little history. The first automobile generators were direct current generators. Cars were equipped with such generators until the early 60s of the last century. Their main difference from alternators is that the electromagnets creating the magnetic field are stationary. EMF is in the rotor windings rotating in this field. The current is removed from the semi-rings isolated from each other, so each brush has a voltage of only one polarity. Their disadvantages are the complex design of the brush collector assembly and low reliability due to the high current flowing through the contacts between the brushes and collector plates. Therefore, as soon as the industry began to produce semiconductor diodes of sufficient power, DC generators on cars began to replace Alternators with semiconductor rectifiers. The rectifiers of the first such alternators for the automobile were selenium rectifiers. They were large in size and their operating temperature was much lower than that of modern silicon rectifiers. Therefore, they could not be placed inside the generator. They were replaced by semiconductor regulators on discrete elements. They were followed by integral voltage regulators with such small dimensions that they were combined into one unit with brushes and inserted into the generator housing. Reliability of generators. The greatest influence on the reliability and service life of automotive alternators is the quality of rotor bearings, brush collector unit and winding insulation. The first and the last factor depends mainly on the level of component production technology. The impact of the second one is trying to eliminate by developing contactless inductor generators with shortened poles. Such generators have been used on tractors and agricultural machinery for decades. They are not yet used in automobiles due to the fact that ways to eliminate their main disadvantages have not yet been found: small specific power, large amplitude of voltage pulsation and significant magnetic noise. Their reliability is noticeably higher than that of their predecessors with brushes. Car alternator. In conclusion, the car alternator plays a crucial role in the vehicle's electrical system by converting mechanical energy into electrical energy. Through the principles of electromagnetic induction, it generates the necessary power to recharge the battery and supply electricity to various components while the engine is running. Understanding how the alternator operates not only highlights its importance in maintaining vehicle functionality but also emphasizes the need for regular maintenance to ensure optimal performance. Thank you for watching, and we hope this video has provided you with valuable insights into the workings of your car's alternator.